Sorry.
Yeah, under the
Romanese. Finishing with vectors motion in space. R is typically your position vector. Velocity is its derivative. Acceleration is the second derivative. Speed is magnitude of velocity. And speed does not have a direction. Velocity does. Of course, I always ask this question when we do velocity and acceleration. You're in your car. How many accelerators does your car have? Accelerators does your car have? 4. Doesn't matter how many. What are the 4? You just told me 4. What are they?
The left front wheel, the right front wheel, the back.
So how many, you said how many accelerators are in the car? One. Car is the body that's accelerating.
You have 3 accelerators. The gas pedal, the brake pedal, and the steering wheel.
That's those are accelerators. Oh, yeah.
What's acceleration? Change in velocity. You speed up, you're changing your velocity. You brake, you're changing your velocity. And you turn, you're changing direction, which means you're changing velocity.
That's true. All relative to Earth, though, because you're moving on in space non-stop, right?
Doesn't matter, the car still has those 3 accelerators. The fact that the car is on Earth, which is moving, has no impact on that.
Okay.
That plane acceleration, so we can break down acceleration into tangent to motion and normal to motion. Right, then that forms your plane of acceleration. You have 2 components of acceleration. You have your tangential component, which again is the component that's in the direction of motion. And you have your normal component, which is the component that's perpendicular to the direction of motion. And something interesting about the perpendicular component, also known as centripetal, it always points in to the center of curve. So when you're going around a bend, your centripetal acceleration is always in towards the center of the curve. Right? Tangential is just if you keep going straight. Projectile motion. Video has the derivation. That is the model for projectile motion. Centrifugal force exerted by a moving particle of weight, capital W, at a point in its path given by capital F equals capital W over G times the centripetal acceleration. We're going to find the centrifugal force exerted by a particle that weighs 5 pounds at the ends of your major and minor axes as it traverses the given elliptical path. R is measured in feet.
And the A sub n is the thing that we're solving for.
No, we're finding F.
Oh.
But we need to find the centrifugal
Right.
acceleration first. So I'm just going to go ahead and plot that ellipse. So there's the ellipse. Right, what we're looking for those 4 points, right? We're on the ends of the major and minor axes. Those 4 points right there, right? Now, let's see who remembers ellipses. Which one's the major axis?
The one.
It's not y. It's the x-axis. It's the larger distance.
Wait, which way? But it's not like graphs, so how do you know which way it's on?
Just get a graph. But without the graph,
Oh, wait, I didn't see the point, sorry. Gotcha. I thought it, was this thing, sorry. I thought it was
so that's going to be the larger. That's how you would tell if you were just have that. You have to actually, you could also convert this into its equation form, its relation form. Right, the A is your semi-major, or the larger of the A or the B is the semi-major. And the variable that is under corresponds to that axis. And then we can really be funky and but then your semi-major and semi-minor are not actual axes. Right, semi-major would still be at longer distance,
Right.
but since it's
It's just shift.
twisted, it wouldn't be an X or a Y. This was our R. For A sub n, I did give it again, okay. Since we don't care about the tangential component, that second formula would be the best one to use, which means we need velocity, speed, and acceleration. What's the velocity? your speed?
Twenty times, wait, what is the magnitude?
Is it?
Magnitude of velocity.
Which is what?
Square root 20 squared sine
What's 20 squared?
400 sine squared t. That's 225 cosine.
What's acceleration?
Negative 20 cosine t.
Negative 50%.
You don't need v cross a. What's velocity cross acceleration? And you can make your life easy. Since velocity and acceleration are strictly in the xy plane, what direction does that cross product point? Strictly in the z direction. Means your first two components have to be 0. What's that third component? Sine squared plus cosine squared. Both are 20 times 15. What's 20 times 15?
300.
Oh, yeah.
Just 300. Which means its magnitude is what? Just 300. You now have your normal component, you have your centrifugal acceleration. We also know two other, and we know the weight is a constant 5 pounds, and we know little g. But we're going to approximate that as 32 feet per second. Those are constant. That means all we need is centrifugal acceleration at each of those points. On the ends of your major axis, what's the value of t? You have two values. So what's t here? Zero. What's t over here? That's 0.
So it's
What's t here? What was it? It's just pi.
Oh, yeah, I'm sorry.
And no, it's not pi revolutions. Be careful. Revolution is a complete return.
Right, okay,
So if you're saying pi revolution, you're saying it's revolving 3.14 times,
okay.
or approximately 3.14 times. So it's just pi.
Okay.
But what's sine of 0 and sine of pi? Wrong one. What is it? Sine of 0 and sine of pi are both 0.
Oh,
What's cosine of 0?
cosine.
What's cosine of pi?
Zero.
Negative 1.
Negative 1. What happens when you square negative 1? What happens when you square 1? Isn't your normal cone of acceleration the same at both of those endpoints? It's just 300 over the square root of 225. 300 over 15. It's 300 over 15. (20 feet per second) is the normal component of acceleration at both endpoints. And remember, they're both pointing inwards. So they're both pointing. Your centrifugal acceleration is pointing in towards the
So
sun.
that's
At those
basically the force that you need to keep that.
No, it's not a force. Acceleration is not a force.
Sorry, the acceleration that's needed to capture.
The centrifugal acceleration is what gives you that imaginary force, the centrifugal force. Right? It's what makes you feel like you're being pushed back. That's actually the centrifugal force. Which is, of course, W over G times that. We call it F sub C. And again, they're both going to be the same. Right? Because weight and G are constant. The only thing that changes is normal centrifugal acceleration, and it's the same at both endpoints. Five over 32 times 20. Isn't that just 25 over 8? And what's the unit?
Per pound.
25/8 pounds. 25/8 pounds. Now, on the end of the minor axes, what are your values for T? Positive, no, values for T. Okay, so what's T right here?
Averaging negative.
Don't use negative pi over 2.
3 pi over
3 pi over 2. Doesn't matter, but we're gonna stick between 0 and 2 pi. Oops. Well, same argument. Cosine at those 2 points, 0. What's sine of pi over 2? Sine of 3 pi over 2.
negative.
And when you square them, you get the exact same value. So normal acceleration, isn't that just 300 over 20 at both endpoints? Which is what? Why are we trying to draw 5? Right, so again, that is actually you have to be careful with the way you say that. Yeah, we write it feet per second squared, but that's not actually counts per it's feet per second per second. Because remember, rate of change is always unit of what's changing divided by unit of time, or per unit of time. Right, so it's feet per second, each second. Just easier to write that than the feet per second and the meter per second. Come up with the conventions. And again, your force at the 2 endpoints are going to be identical. Because essentially, your force is going to be determined by your normal acceleration. And what's that? What did I do? 12. Be 32. There you go. This one's cool. So the next 3 questions are going to be dealing with projectile motion. Right, first we're going to put it in the form y equals f of x. So we're not going to write it in vector notation. Then it wants us to find the range. And by definition, range is the horizontal distance that's covered during its flight. And find the maximum range of a particle. Sadly,
Question. Will you be going over the test? Like, will you be going over the correct answers to the test in class or no?
no, I don't go over them in class. I do post the solutions, just like I did with the quiz.
So I guess I'll let me go over them with you just
Schedule appointment or stop by during my office hours, and then I'm more than happy to go over them.
Okay.
But like I said, I do post the solutions as well.
Yeah, I just
So
like
if
I
you
was
read the solutions that you're stuck on something,
I
then
thought I knew like what I was doing going into it, and then I got to some of the questions and I was sitting there and I was like, there's no way I'm doing this right.
yeah, I promise you, you're gonna look at the solution and face palm.
Yeah.
Usually what I find is,
I'm hoping that it's just like first exam, and I was kind of.
but what I find is a lot of students do that. They're like, "Oh my god, I thought I knew what I was doing, but I did this completely wrong." And then they look strictly up.
Probably not.
I overthought that.
Probably. problem 8 and 6B, I was just like, what is going on?
Which one was you?
8 was the drone
The
problem.
drone problem?
Yeah.
I thought that was in.
8 was,
Part of
I
that.
think that one was the one that was put on there to see if you really know what you're doing. That's the,
Oh, yeah.
if you want to get an A, you have to really know what you're doing.
Okay, good. Okay, I'm glad.
I try to put at least one of those questions on
6B
each.
Was that the cylinder one?
6B was the cylinder one, and it was like find
Clear the dirt.
Yeah. Yeah. I was like,
I promise you don't call that one.
Oh, I get it.
Yeah, that one, yeah.
I was like, I have no idea what's going on.
So, we leave it to.
Right, next class, we'll finish this up, do the worksheet, and then so there was a change in the syllabus. I did update it online, so just make sure you look at, I totally forgot to put partial derivatives on the schedule. So I had to, so I combined multivariate and limits and continuity together, and then replaced the limits and continuity with partial derivatives. So just look at the change on the schedule. But that's really it. Nothing else really changes. So that's next time we finish this up, we do the worksheet, right, 10-minute break, and then we start multivariate functions.
Yeah.
And keep your eyes peeled on the messages because it's supposed to be really hot again on Wednesday. So depending on how tomorrow goes, since I'm getting the exam tomorrow, and how sick I feel Wednesday, that may be a virtual meeting.
So tomorrow we still have.
Yeah, because the same thing as today, because it was an exam, I just made sure to come in. But if Wednesday's really bad, I'm sick because of the heat, I'm gonna make that virtual. So just keep your eyes peeled on the messages.
It was brutal.
My laptop camera's broken, so I'm going to turn on my phone.
Also, are we getting points off for reading the simplified way?
Depending on the simplification.